Welcome to EDU World Space.
This question is asking us to determine for 3 different compounds if geometric isomers exist, and if so, how many are there? And it first gives us this tetrahedral complex, which it tells us that it's a tetrahedral. So we'll go ahead and draw that out, where we have the metal ion, Cb, we have 2 waters and 2 chlorines attached. And so I'm just going to put these in any order, OH2, and then I'm going to draw this Cl, 1 Cl coming out of the page, and 1 Cl coming out of the page, and 1 Cl going into the page. And for this tetrahedral type complex, where you have four ligands total, 2 are the same, and then the other 2 are the same. No matter which way you orient these ligands, you have no geometric isomers. So there are no geometric isomers. This is a trait for this particular type of complex. And if you have a modeling kit at home, I highly suggest that you get that out and look at this type of structure so that you can better visualize why this is the case, where if you rotate it upon any of these axes, you'll always be able to get back to the same structure no matter what way you put these ligands onto this molecule. For part B, we have a square planar complex, which is this guy here, and we'll go ahead and draw out one of them, where you have C2 coming out of the page, and 2 going into the page for a square planar, and you have chlorine, another chlorine, and then it's supposed to be a P, sorry. Got a pH3 and a pH3. And this complex has a negative charge on it. Now, with the square planar molecule, you could imagine if this is your cis complex, you can have a trans isomer where you have IR, this Cl, pH3, but now you have pH3 on this side, you have the Cl on this side. So now, no matter which way you rotate this, you'll always have the Cls across from each other and the pH3s across from each other, whereas here they are next to each other, and these are distinct isomers. Again, that's a negative charge on that. For part 3, we have an octahedral, so this has 6 things coming out of it, where we have the iron, and then this O-phenyl, which is a nitrogen-based compound. So we're going to show that by a nitrogen, and then another nitrogen, and a loop between them. And you can have, we have 2 of those. So just show the loop between those, and then you have Cl, the Cl coming directly above and directly below. Now, you could imagine the way that these molecules are oriented can be a couple of different ways. So a second isomer, is where we have the chlorines right next to each other. So chlorine, and then we still have our then like this, then, and then we have one more isomer, which would be the enantiomer of this guy, and so that means the mirror image. So we can draw that where we have the chlorine, and then the mirror image would have this chlorine here, this then here, this then here, and then this guy that way. And now this is where the modeling kit can come in real handy, because it's a little hard to tell that these two molecules are distinctly different, but it has to do with how these O-phens connect, and sort of like blades of a fan, you can think about it, where you have one coming out and out and in versus in the plane and coming towards you, and this has that exact opposite, which is different. You cannot superimpose those, which makes them enantiomers and multiple isomers.